So here we have a question about frogs and toads, both of whom have fallen down a well and then attempt over the course of several days to get out of the well and escape. So the first part asks us about the height of the toad at the end of the second day. So to understand this, let's draw a picture of the well 50 feet deep. There's the ground level up there, so that's 50 feet above the bottom of the well. And we have the toad sitting down at the bottom. Now if we look at this recurrence relation here, we're told T1 is 13, where T1 is the height reached by the toad at the end of the first day after falling in. It's important to know what values, when the values are assigned to these letters. So we're told that the toad basically climbs 13 feet up the well, and that's when we measure the value of T1. That's the height reached at the end of the first day. Now we're told that overnight it slides a quarter of its height above the floor down, so it's going 1/4 of this. It retains, notice, 3/4 of its height. There's 1/4, the rest of this is 3/4 of the height achieved. So it slides back 1/4, that's retaining 3/4 of its height, and then proceeds up 13 feet until the end of day 2. At this stage it slides back 1/4 of the height that it's now reached and slides up another 13 feet to get to this height. So let's see if we can work out what T2 is. We're told that T1 is 13 feet. This is part A. And we're told that to calculate how far up it is after the end of the second day, we have to work out 3/4 of the height that it retained in the first day. So 3/4 of T1, and then it moves up another 13 feet. So we have to calculate 3/4 of that original 13, the height that it moved up during day 1, and then add 13. So 3/4 of 13, that's 39 divided by 4 plus 13, and 4 into 39, 4 9s are 36 with 3 left over, so that's 9 3/4 plus 13, that's 21, 22 3/4, or 22.75. So calculate the height of the toad at the end of the second day. There it is, 22.75 feet. Now part B involves discovering what happens in the long run. So we know that to find the height at the end of any of the days, you look back at the height it achieved the previous day, retain 3/4 of that, and then up it goes another 13 feet. Now this recurrence relation, going from the height on the end of day n to the height at the end of day n plus 1, we know that there will be a limit to the sequence of values. We know it starts off at 13, then it achieved 22.75, and we can calculate the next one after day 3 and so on. We get a sequence of numbers. It will steady out, it will achieve a limit, a fixed number that it won't change thereafter. And we know this because this multiplier 3/4 lies between -1 and 1. So we would have to state this, that a limit L exists since the multiplier, in this case it's 3/4, lies between -1 and 1. So if that's the case, then if we've reached that limit and we take 3/4 of it and add 13, will be exactly the same height again. That's what a limit means, that you do the calculations in this recurrence relation and then nothing changes. So let's multiply both sides of this equation by 4. We get 4L equals 4 times 3/4 would be 3L plus 4 13s are 52. Take 3L from both sides, L equals 52 feet. And since L is greater than 50, eventually it will escape from the well. The frog escapes. Sorry, the toad. We'll get to the frog in a wee minute. The toad escapes. So let's look at the hapless frog this time. And in this case, what happens? Frog's height, he slides back down 2/3 his height. So he only retains 1/3 of the height of the previous day, and then he seems to be doing better than the toad. He goes up 32 feet. So he's sliding back a larger proportion of what he's achieved the previous day. And how do we start out with this one? It starts out at 32. But that's not important. In the long run, what happens? Is there a limit? This time the multiplier is 1/3. So again, a limit exists. Say M. In this case, this is the multiplier. It's 1/3 this time, and it lies between -1 and 1. So let's do the similar type of calculation. If we've reached the limit, then in this case, 1/3 of that value plus the 32 will get exactly the same value. So this time let's multiply by 3 both sides. So 3m equals m plus 96. Take away m from both sides. 2m equals 96. So in this case, the limit m is 1/2 of 96, which is 48. And we'd say that since m is less than 50, this up here, this frog never ever gets beyond this 48 mark, so it just cannot escape from the well. So since m is less than 50, the hapless frog cannot escape.